In this lesson, we are going to learn what it means to use Excel to calculate percentages. Now, the corporate world perform mathematical operations that provide insight into the world of business analytics. In this case, calculations such as percent of total, variance to budget, and running totals are very important in every basic business analysis. When you are asked to calculate a percent of goal, it means you are required to compare the actual performance against the stated goal. And so you simply divide the actual by the goal, and it gives you a percentage value that represents how much of the goal has been achieved. For example, if your goal is to sell 100 products and you sell 80 of the products, your percent of this goal is 80%. That is 80 divided by 100. In our usual mathematics, it would be said divide 80 by 100 and multiply by 100 to get the percentage. Check and see that they are the same. Just that the former gives decimals, but we would apply a percentage formatting in this case when we are using our Excel. So let us depict the scenario we just described. So if you enter equal sign and then 80 divided by 100, now Excel will display it in decimals, which is 0.8. So we can apply the percentage format and then it will now turn to 80%. Let us go to the table in the worksheet, the first table. Now the table here shows a list of regions, north, south, east, west, with a column for goal and a column for actual. Note that the formula in cell D2 simply divides. So for instance, over here, let us see something. This is D2 actually. So this one is D4. So the formula in D4 simply divides the value in the actual column by the value in the goal column and can be applied as well to D5 all the way through to D7. And so thus, if we want to enter the formula, we resume with our equal sign and then C4 divided by D4, and then we press enter. And then you can take advantage of the autofill handle and then you drag it down to fill in the values automatically. When you are done, you can apply the percentage formatting and it will convert everything to percentage. Now, alternatively, if you need to compare actual values to a common goal, so for instance, in this particular table, we have a common goal which is $700,000, and so we want to compare the actual to the common goal. And so recall what we learned about referencing format. When we use the absolute reference to a common goal, so for over here we use the absolute reference. Here we type into the formula an equal sign, then we have our G7, then we divide by, so we are going to use this one as our relative reference. This will become our absolute reference. So G7 divided by, because we want to refer to this one as an absolute reference, because this is a value that is going to run through across and it should not change. And for that matter, we apply the dollar symbol. So we open the dollar symbol, and then this common goal is found in cell G4. And so we apply the dollar to the column letter, which is G, and then another dollar to the row number 4. Okay, and then we press enter. And so when that happens now, we can drag it using the autofill handle and it will fill it automatically for us, and then we can apply the percentage formatting. So what we see here is that when we click on this result, you can see it is G7 divided by a common goal, which is the 700,000. And so this is exactly what is displayed here in percentage. And then when you click on this one, now over here you see G7. When we click on this, it will now tend to G8 because it uses a relative reference here. But over here it remains the same because it is an absolute reference. And so when we click on this one, you see what has happened. So this is a relative reference to G8 dividing this same value. And when we click on this one too, this G9 is also dividing this same value. And that is how we make use of relative and absolute references. Now, at a point in time, we would also like to calculate the percent variance. Okay. To calculate the percent variance, we ask ourselves, what is the variance? Now, a variance is an indicator of the difference between one number and another. So to understand this better, let's imagine that you sold 120 products one day and sold 150 products the next day. Now, the difference in sales is very easy to guess. You sold 30 more products on the second day. That's 150 products minus 120 products gives you a unit variance of 30. So what is a percent variance then? It is essentially the percentage difference between the benchmark, which is the 120, and the new number, which is the 150. You calculate the percent variance by subtracting the benchmark number from the new number and dividing that result by the benchmark number. That is, subtract 120 from 150 and divide the results by 120. So this will be like an equal sign. You open parenthesis 150 minus 120, then you close the parenthesis and you divide by 120. And so we also want to avoid Excel's built-in precedence. That is why we have specified a parenthesis. Okay, so we have wrapped this particular expression in a parenthesis so that Excel will consider our order of calculation for the formula we have entered, and then you press enter. It will give you the value, and you can apply the percentage formatting, and you get the result. And so that is how we work with this. But this time around, we would like to demonstrate this on the worksheet. So one thing you should note is the use of parentheses over here, like I said initially. So when you click on this one, the formula in the formula bar, we have the parentheses. Okay. So we discussed the Excel's precedence in our previous lessons. Now, after calculating the percent variance, so how do we calculate the percent variance? Now we are going to enter our equal sign, okay, and then we will have open our parenthesis, and it is going to be our new value, which is the current year, minus our old value, which is the prior year. Then we close the parenthesis, then we divide by this old one, and then we press enter, and it gives us a value of 9%. And so you make use of the autofill handle, and then you fill in the rest, and it gives you the corresponding values. Now, after calculating the percent variance, you notice a negative sign. And this is what happens when your benchmark value is less or even zero. This is the benchmark value we are talking about. So either it is less than the new number, and so or it is equal to 0, then definitely it is going to give a negative percentage. If we interpret the percent variance as budget, how can we report a negative percentage? In the corporate world of business, we may say it is a loss or something like that if you consider it profit after sales. But must the percentage value be negative? No, it goes against everything we have studied in our math class. So to fix this, we leverage the ABS function, which negates the negative benchmark. So for instance, if we have something like this, now this over here you see is standard PV. The PV is percent variance, so standard percent variance and improved percent variance. So what we are going to do is to enter in a formula just like we have done here, and so we will enter in an equal sign, we open parenthesis, and we have actual minus the budget, and then we close and we divide by the budget, and it will give us negative 220%. Okay, and so like we said, we do not agree to the fact that we can report a negative percentage. It's a value in percentage, and then it will be difficult for you to interpret if it's negative. So we make use of the ABS function, and this is how we make use of the ABS function. We're going to do that just now. And so you will enter your equal sign, you open parenthesis, and then your actual minus the budget, you close it, you divide by, then you apply the ABS, and you open parenthesis. ABS of what? ABS of the budget, and then you close it and press enter, and it will report a positive value. So if you write a negative value like -8, and then you apply the ABS function to the -8 like this, so we have to begin with an equal sign. It's a formula. So our -8 in here, and then we close the parenthesis and press enter to report a +8 value. And so that is what we are doing. So the ABS function will negate the negative value so that it reports a positive value for you. And so we proceed on to learn how to calculate the percent distribution of total. Now, the percent distribution is a measure of how a metric such as total revenue is distributed among the component parts that make up the total. Okay, so let us go to the worksheet again, like we have here, and look here. We have depicted total revenue of the regions, and we are going to calculate percent of the total. So we make an absolute reference to this total, just like we were dealing with the common goal previously or earlier on. And so here we make an absolute reference to the total and enter the formula into the cell here. Thus, as our equal sign, this value will be divided by, this is the absolute reference we are going to make use of. So we make use of the dollar symbol. So we enter our dollar, and then this value is located in the U column, and which row? 32. So it becomes our dollar applied to the column letter, which is the U, and then our dollar again applied to the row number, which is 32. And then we press enter, and it will give us the result as 40%. Now we can use the autofill handle to drag it, and we'll get the remaining result. And so that is how you calculate the percent distribution for each region. So the whole thing is that it is just like we have divided each region's revenue by the total to get a percent distribution for each region. Now, at the point in time, we could also have used the sum function to calculate the percent distribution of total, and that is how we do it, is like this. So in this cell, you enter the equal sign, and then you have this particular value divided by, now the rest is going to be the sum of all these, okay? The sum of all these values, which will render the total as we indicated here. So instead of making an absolute reference to the total, we are rather going to divide by the sum of all these. And so we type the formula, the sum, and open parenthesis, and it's a range, okay? So this one is found in the Y column, and then the 27th row. And so we type in Y27, okay? But because we are going to, so let me go back to the formula, and then, so because we are going to specify a range, now what we are going to do is to apply the dollar symbol, so that it is more or less like we make an absolute reference by using the sum function. We make an absolute reference to the sum of all this range, okay? Now in this range, if you are specifying the range from here to here, it would have been Y27 colon Y30, okay? But because we want to make an absolute reference to the sum of these values, we use the dollar symbol. So the dollar symbol is applied to the column letter, so Y in that range, and then another dollar symbol to the row number, which is 27. Then we specify a colon, okay, because we are specifying the range. We want to sum the range. And so we apply the dollar symbol again, and then, so it is more or less like from Y27 absolute reference, okay, Y27 up to Y30. And so we have Y and our dollar symbol again, and then 30. So you can see it has specified the range, and we close the parenthesis like this, and then we enter, and we have the 40%, just like it is indicated here. And so you can now use the fill handle and then drag it across to get our respective values, and they are the same as that. So either you make an absolute reference to a specific total, or you make the absolute reference to the sum of the range, and you will still be able to calculate the percent distribution of total. Now, another thing that we would like to consider before we progress with the percentages is to go to the running total. So though we are still on the percentages, we would like to know how to calculate a running total, okay? This is because organizations or businesses like to see a running total as a mechanism to analyze the changes in the metric as a period of time progresses. So let's look at this particular table we have here, and let us type into cell D3 the formula, and you must watch carefully. So equal sign, because here we are entering the formula for a running total. So please watch very carefully. So equal sign, and then we specify a sum, okay? The running total is going to act like a cumulative frequency. So you are going to add this value. So this value will begin at 78, and the 78 should add up to this to get this value. The 78 plus this should get a value here. So it keeps on accumulating itself until the end of the year, so that we might know how many units that have been sold throughout the entire year. And so here we open the parenthesis, and then make an absolute reference to this particular number because it keeps on adding itself. Like I said, you will add 78 by itself in this particular range. When you specify the formula, it will do that for us. But over here, it will be 78 plus 63 so that we'll know how many units have been sold in the month of January and February. And then we can also add the 78, 63, and 38 to get this particular value. And then 78, 63, 38, and 17 to get this particular value. So you see the 78 is an absolute reference. It keeps on coming in each cell we want to find a sum. And so if we want to make an absolute reference to this 78, we use the dollar symbol. If you remember, we apply the dollar symbol to the column letter as well as the row number. So the dollar symbol to the column letter, and the column letter here is C, and then that is 78 here. So the column letter is C. So we apply the dollar symbol to it, and then the dollar symbol to the row, which is the third row, so 3. So you see it has selected this particular value. And what we want to do is that it is going to be a range. So we specify a colon after the absolute reference, and then now enter our C3, and then we close. So what is going to happen is that this is an absolute reference. It does not change throughout the formula when you paste it here. But this one will keep on changing because this is a relative reference. So in the next cell, it is going to be the same formula, and this one will not change, but it's going to be up to C4. So it is more or less like you are going to sum 78 plus C4, and to give you this result. Over here, it will change to this same formula. This one will change to C5. So it is going to be like sum this value all the way to 38, and then you get this value. So it goes on and on. And so now I'll press enter and get my value, which is 78. So I use the autofill handle and then drag it down to this end, and it will keep on adding itself. So if you look at this formula, for instance, like here, it means that if you look at the formula, it is the sum of the absolute reference, which is the 78, all the way to C7. Okay, this is the 7th row and the C column. So all the way to C7. So it keeps on doing something like this. Is how we calculate a running total, especially when you want to track the number of units that you sold in each month, and then you'll be able to accumulate how many units you have sold at the end of the year. Now let's go back to our sheet again, which is the percentages, and then we will continue. Now this time around, we are done with this part, so we are moving on to applying a percent increase or decrease. Applying a percent increase or decrease. Now, as an Excel analyst, it should be a common task to apply a percentage increase or decrease to a given number. For instance, when applying a price increase to a product, you would typically raise the original price by a certain percentage. Also, when you are giving a customer a discount, you would decrease that customer's rate also by a certain percent. So we would like to illustrate this here in the worksheet from these two tables that we have illustrated here. And so we've come this far so that you will be able to use, as you can see, we have even moved beyond the column Z. So we are beginning A, B, and like that. And the reason is that we've come this far because we want to know how to be able to use our formulas. Even when you are working with large data, you'll still be able to specify your formulas and define your cell range or the cell addresses. And so in this particular cell, which is AE34, in this particular cell, we have to type in the formula, and I will explain as we do that. So AC, so our formula is going to be AC34, which is this one, AC34. So 34. Okay, I could have just clicked on it and it will enter automatically, but I want you to know the order of how we do this. We enter this particular formula. So we multiply this value by, then we open parentheses and say 1 plus this value, which is AD34. Okay, and then we close the parentheses. Now, before we press enter, I want to explain. The issue is that to increase a number by a percentage amount, you will multiply the original amount by, so this original amount, by 1 plus the percent increase. So this one here represents 100%. if you have 100%, it is 100 divided by 100, and that is equal to 1. And then over here, this AD34 is actually the percent increase, which is a 10%. And so it is more or less like 10% is 10 divided by 100, that gives you 0.1. And so 1 plus 0.1 gives you 1.1, and you multiply by that, and you will still get the same answer. Or we could interpret it as the one here is 100% we are talking about, plus the 10% increase. Okay, but the 100% is actually 1. So 100% plus the 10% increase. Then we want Excel to perform this calculation before multiplying by the original price. And so when we press enter, it will give the result as 110, because 10% of 100 is 10. And so if the unit cost has increased by 10%, it has increased by 10. And so you add 10 to the 100 and you get 110. And also over here, we are looking at a discount here also. And so to decrease the number by a percentage amount, because it's a discount, you multiply the original amount by 1 minus, so let me shift it here small. Okay, so 1 minus the percent discount. And so we have to also enter in the formula. We begin with an equal sign, and then we are going to multiply this value, which is AC38. We multiply, then we open parentheses, 1 minus the discount percentage, which is 20%, but it is a cell address. So you can click on this and then it will enter the cell address here, and then you close the parentheses. So let me explain in a very small way. And so it is just the value times 100% minus the discount. Okay, so this particular cost percent, which is 1000, actually says that it is 100%, and there is a 20% discount. So if you take 20 from 100%, you get 80%. So it means that you are giving the person at a cost of 80%. And so you will take 20% from 100%, and 100% is 1, and this particular cell address is the 20%. So we are taking the difference between them. Excel performs this calculation in the wrapped parentheses and multiplies by the value 1000. And so when we press enter, we get our value as 800. Now, another important note during the process of division, let us go to this sheet. Another important note of during the process of division is when the denominator is 0, it becomes a problem. For instance, if you divide 4 by 0, let me do it here. If you divide 4 by 0, now you will get this particular cell error. Okay, this means that the number, if you remember when we treated in our previous lessons, the meaning behind some of these errors, this means that the formula is trying to divide by 0. Okay, because we specify the formula as 4 divided by 0, and then Excel will recognize that as an error. But mathematicians call the results you get when you divide any number by 0 undefined, infinity. That is how mathematicians call it. But sometimes for easy calculation and simplification, we will normally use 0. And so if you do not want Excel to report the error term, but first of all, let us demonstrate how it works over here. So percent to budget, it means that we are going to find the percentage of actual to budget. So we divide actual by budget and then change to percentage format. And so over here, we can specify our equal sign and then this value divided by this. So D3 divided by C3, we press enter and we get 100%. And actually, when you use the fill handle and you drag to the last cell here we used to calculate and you release, it will now give you the values. But over here, it says that the formula is trying to divide by 0 because it is actually 100 divided by 0. And so Excel will recognize that as an error term. Okay, now we can correct this particular problem. Okay, we can avoid this particular error problem Excel gives by telling Excel to skip the calculation if your denominator is a 0. With this, we use what we call the if function. And in our previous lessons, we talked about how to use the if function, and we said we'll discuss that later. So now we are here and we're going to work with the if function. Let me delete this one. Okay, so we are going to solve this particular problem by using the if function. And now a typical if function, the if is if, okay, in capital letters. A typical if function has 3 arguments, okay, and they are, the first argument is the condition, so it states the condition. The second one is what to do if the condition is true, and the third one is what to do if the condition is false. So if you use the if argument, what you're trying to do is that you will state a certain condition for Excel, that if this condition exists, then tell Excel to do this when it is true that it exists. Otherwise, if it is false, then Excel do this. So you are going to tell Excel what to do with that, and that is exactly what we'll do to solve this particular problem. And so let us look at this over here. Now in cell E4, we enter the formula. Let's see how we're going to correct this particular problem. So in cell E4, okay, we enter the formula D. So we have to start with an equal sign. So D4 divided by C4, and it will give us the same problem because it is going to divide 100 by 0, okay, and it will still give us the same problem. And so what are you going to do now? To use the if formula, we can correct it. And so what we're going to do is the equal sign and then the if function, then you open parentheses, and what you're going to say is that if C4, now we're going to state the condition. Like I said, the if function has 3 arguments. It has a logical test which says that if C4 equals 0, okay, that is a condition. So the condition is that if the denominator is 0, if C4 equals 0, then what? So what should Excel do if that value is true? What should Excel do if C4 is 0? That is how it works. So let us try to look at the analogy here. So if C4 equals 0, this is a condition, then Excel, I command you to enter the value 0 if C4 is equal to 0. Now, what if the value is false? What if it is not equal to 0? Then what should Excel do? So you are telling Excel that if this condition exists, that is C4 is 0, then you enter the value 0. If not, that is if this value is false. If not, then simply divide D4 by C4. That's all. And then you close the parenthesis. So this is how you specify the if argument. So if C4 equals 0, Excel, I want you to enter the value 0 there. If it is not, simply divide my D4 by C4. So when you finish, then you can now press enter, and it will have corrected the problem for you. So all that this is trying to do is that when our denominator is 0, the if function has specified that if it is 0, then Excel, please do enter 0 into the cell for me. But if it is not, then please simply divide my D4 by the C4 and then give me my result. And this is how we can correct some of these problems.